So I'm very, very happy to be here finally. There was a plan to come last year, but my son was 2 months old and going to US was impossible because I would have booked the flights before he was born. So I'm super happy to be here. The plan was to have the robot here, but he can't come up the stage because it's apparently too big. The plan was to have it here, but it needs to be the emergency exit. So it's outside. So I have actually the super great opportunity to adjust all my slides and answer all your questions I collected yesterday. So I think that's a super great opportunity. And I'm the global product manager on ABB Robotics side. So I'm the one actually preparing how our robots will be programmed in the future. And I think that's a super exciting time at the moment. I will start with a few background things on robotics because I think that is important to understand why we started with this Wizard-easy programming. Then I will show you something with the virtual robot on here. And I also brought some videos of real application examples because that's what you asked for. And then we will move outside. You will see the real robot. And during lunch, you can actually also have some hands-on. How does an ABB robot look like? So you can see the one outside, but actually they can look very different. It can be kind of mobile platforms. It can be 4-axis robots. It can be lightweight hanging robots, paint robots, the big ones. So they can look very, very different. The smallest one is like 43 centimeters and can lift up to, or the smallest one can lift 1.5 kilo. And the biggest one can lift up to 800 kilos. So it's really like very big next to me. And the very, very nice thing with ABB Robotics is that they all are programmed in the same way. So everything I'm showing you now is applicable to basically all of those robots. One platform, and you can apply it to multiple applications. So what are those robots actually doing? I think very, very traditionally, that is what people assume people are doing. Robots are doing, sorry. So they work in automotive industry, and they are programmed by experts. And I think that was true for a very, very long time. But what we see today is they moved into a lot of different applications. It's in lab testing, it's in painting cars, but it's also painting little toys, dolls. So it's really painting by pixel. They can assemble the Raspberry Pi, welding, 3D printing. They can make pizza. Very, very traditional. You have a lot of pick and place, machine tanning, palletizing, packaging, but also inspecting things. But then we have very, very customized application coming. We not even know what they are. Can be construction, but can be any other. I think the sustainability area is also bringing a lot of new things in battery assembly, trash sorting, baking the fiber plates. So it's really, really, really a big variety. So from our side, we actually don't know all of those things. We know a lot, but not all in detail. So we need to provide basically something where people can build on top. And the trends we see in the last years is there is still a very big complexity of robotics integration. And you can compare it to flat pack furniture without any instruction. Then there's a demand for customization. And I think on a phone, the very normal thing is you install the apps and the things you want your phone to actually get done. And that is what is coming to the industrial robot side, because in the past it had been purely experts. And now basically everyone should start to have a hands on the robot. And the last thing is, when you look in the industry, there are a lot of easy-to-use tools. But with most of them, when you start, you can reach a certain limit, and then you need to throw everything away if you want to go to higher complexity, and you need to start from the beginning. And at ABB, we said that should not be the case. So whenever you start, you should go all the way up and scale to the needs you actually have. And we have more than 160,000 ABB robots out in the field. We have more than 11,000 employees in ABB Robotics. And I think we are kind of proud also to really leading the way of the innovation. And that started with kind of the very first electric microcomputer-controlled industrial robot. Back in 1974, we had the first cobot, actually, even with 2 arms. And we had the Wizard Easy programming, the block-based programming, at the very, very first one, actually already in 2018. So when I look at this Wizard Easy programming, we promoted it as really the idea, now everyone can program robots. And that's kind of true, because you can insert the blocks. What is also very nice, we support 9 languages. So whenever you read through the program and you change the language, actually, I mean, also the order is changing. So in any of those languages, the operator can even read what the robot is doing. I think what we forgot to promote at the very beginning, but I think it's equally important, Wizard Easy programming is also very important for experts. Because at the end, I mean, you can create error-free code in a very, very fast way. Experts can create even their own custom blocks. We have a separate program for this. And in the background, we round-trip the full program to our native ABB Robotics programming language, Rapid. So if you change a Blockly, it's round-trip to Rapid. But if you change a Rapid, it's also round-trip to Wizard Easy programming. And that makes the most sense when you think about we have a huge service organization. They're all trained on Rapid. So when they go out, they can help the customer without even need to look at the Blockly. Yeah, and then last but not least, if they want to enable some custom structured program, they don't need to recreate it because they can just use it. And I think that becomes more clear when we look at this. When they write some very custom code, like for a screwdriver, it looks in Rapid on the left. When we round trip, it just says custom code, which I think is not so easy to read and not very user-friendly. But they can, out of this, create their own code. So here, that is the same, but with custom-made blocks. So here you can say what are the things they actually want to allow the operator to change. So they want, for example, to say it's a pick or a place, it's tightening or loosening screws, and maybe also the tool, which screwdriver it is, screwdriver 1, 2, 3. And when we look at this, I think the Wizard Easy program is going exactly in this direction. So it's really making it easier, but then it's also allowing everyone to customize and add those blocks. But also, since it's Rapid in the background, you can really scale. You can start with a very easy movement program, can add custom functionality, but then even an expert can just continue who's used to just Rapid and can continue. And with this, I will do some demo actually with our virtual robot. So we have the program called Robot Studio. So that is something in education, you can actually get it for free. So you can use a virtual robot like I'm showing it here. In industry, you can use it with a real robot for free. If you want to use this virtual version, you are actually buying it. So what we can see here is a machine-tending industrial bigger 6-axis robot. So we can see, if I started, we can see the part coming in on the conveyor. And then the robot would actually start to pick it. So in this case, we also have another operator interface here. So I need to click one more time, start. So here we can see that the robot is picking it, putting it in the machine. And then later, it will basically also take it out. So now we can see the machine closing, taking the next one. So I think that is one of the most typical robot applications. And then you can say it's putting it inside this area. So that's an air cleaning area where you remove the oil and everything. And usually when you want to remove the oil, I mean, you really want to move it somehow where the part is. So let me just stop this. So usually you need to adjust this path where it's actually going through the air cleaning area, but everything else most likely stays the same. So in order to do this, basically we want to allow the operator to modify. So what we can see here is when we open the wizard program, that is how it looks like. And initially people started to add a lot of movement positions underneath, more than 100 blocks. And there's no way that an operator is looking through this, especially on the teach panel we have, which is not so responsive. So actually, well, we had quite some difficulty to teach people, but that they need to structure the program. So now you can actually read through what it's doing, but you can also go inside. So when we go inside, for example, and say, get a piece, I can go inside here. And then you can see this, for example, the closed gripper is a custom-made block. And this block I can also connect to a user interface, because at the beginning people try to squeeze everything into the block, like an IP configuration, like some manual operations. That is not what the blocks are for. Because, for example, when you want to open and close a gripper, it's much better to do it on a screen like this manually, but you don't want to have it in your robot code. So what you've just seen is we have this little icon here, and I can basically connect from here to, if I click on it, basically this screen very specifically for the gripper. And I can also connect the other way around. So if I just said we want to modify just the path for the air cleaning, so we want to lead the customer directly to this path. So we can say go to wizard. And in this case, you can see it's opening directly in this process for the airflow. And then we have a very, very nice combination as well. So here, I can actually insert blocks, either via drag and drop, so you can see them basically here on the left side, but I can also insert them when I press a button. So in this case, I'm not doing it here, it takes a little longer, but I would move the robot to the next position. And then I can actually press my button 1. And you can see it's automatically inserted the next blockly block with the exact position the robot is in. And then I can also choose my specific air data. So what is air data in this case? I can directly modify it here. So it's, for example, the air speed, which can be different for different parts. So all this is basically here together. And if I think about just moving the robot, pressing a button, moving the robot, pressing the button, that's the fastest way to create a program, even faster than any expert can write the code on the teach pen at least. Copy-paste might be faster, but then you don't have the robot position. Yeah, and then this is the skill creator. So when experts want to create these custom blocks, we have this separate program, so they can go in here. They can select which type of block it is, and then they basically write how it's the order of the blocks and everything, and then what is generated in the background. Yes, and then one more nice thing. A few years later, actually also our department for the robots which are moving adopted the wizard idea. So also those are actually programmed with a Blockly programming language. Then I promised to bring some examples. So we have some default blocks we provide. So for example, for the robot you can see at the outside, they have force torque sensors in the arm. So we have some blocks where you can actually move the robot and it's searching towards a direction. And this is a block you can, as I said, just by default find when you get the robot. Here's another example, very similar. So it's actually searching for the hole, and it's doing it by supervising the force torque sensors. When do we need to have easy programming? So when an application is running 5-10 years and you don't have changes, you don't need easy programming. You will find an expert, and it's probably cheaper to pay the expert. What we see is that more and more customers have the need to actually change it on a regular basis. So what we can see here is for welding. So maybe today they're doing these parts and they just have this circular welding. Tomorrow they do another part, but they need to adjust the path. The application typically is not changing. So we rarely see one robot used for one application today and a totally different tomorrow. I think that will be in the future, but that's not today. So the only thing which need to adjust it is the path again. And here you have the problem that, I mean, it's a still kind of more dirty environment. So people are also wearing gloves, and having this block lead drag and drop is not going to work. They're also not using a mouse. So what we created here is actually we use this same technique of pressing a button. So we added this device actually on top. So here you can actually choose different type of blocks. So it's a move welding linear, move linear, move in a certain way, and then you also have the welding instructions. So whatever you choose on top, and then you press a button, it's inserting a different block. So, and by doing this, the people are basically just grabbing the robot, moving it along, choosing which block need to insert it, and pressing the button, and that's it. And in a similar way, you can actually do it where you can see here on the right. So that is polishing a helmet. So here, basically, they can press a button, or they can even record the path, and then you have just one block saying, follow the record path. Yeah, and then I think the most important thing, and that is what I would like to show here, it's a demo application. We need to work typically together with a lot of other devices, because there is a camera. So in this case, the calibration of the camera should not happen in the robot program, because you just do it once. So that is happening in this screen. You set up everything. But then you need to have the blocks for the robot saying, take a picture, pick the part. So that is basically what we ask the suppliers to provide. So they build the blocks, and they provide a ready software package actually for the camera in this case, and that is another one for the feeder. So the feeder comes with this package of this screen, but then also basically those blocks to execute and program the feeder. Same with the gripper. So you have, as I had the camera, you have the feeder, you have the gripper, and it all need to have some blocks to be programmed. This is how the blocks look like for this gripper. So that does not need anything. And then in this case, we actually really programmed the full program with the blocks. And here again, you can go inside, you can see what it's doing, and it's using, as said, all the blocks from our ecosystem partners. And I would just jump to the very last one so we can see it also running. So it basically took a picture, we picked the chocolate, then you can see it's taken another picture, no part there, it's checking again, checking for another one, find something, pick it, place it in the box. And I think that is a very common application when you think about you have those sweets, but you need to pack them just for Christmas or just for Easter, and they need to be just hundreds of them or very special for this customer. Yeah, so that's basically how we created this little box.